Good morning, good afternoon, good night, wherever you guys are tuning in from. This is Ashwin Murthy, and I'm super proud to be hosting Hermann Gier, co-founder SPL, and Xavier Metzger. Did I get that right, Xavier?
Yes,
Perfectly.
Vice President Sales of SPL. I had to get that down for like 2 minutes. Vivian gave me like a tour of how the names had to go. But super nice to be hosting both these both these people. Herman is just for the past 20 minutes we've just been having this chat where he took control of the stage. So I'm just going to be a spectator today. I'm going to let him go over. Today's agenda is on signal processing and summing. Two things that I, as a composer engineer, am super happy to be, talking and interacting about with, because, after the music is recorded or while the music is being recorded, what do we do? How do we get it out to the next stage is where the processing and the summing stage of things come in. So it's very interesting what will happen here and how SPL can take that to the next level. So Herman, please take center stage.
Yeah, thank you. And hello, everybody. I guess I see a few people here who joined us again. So I'm really happy that you continue to be with us. Again, if last session was really cool because we had a lot of things going back and forth and we were talking and chatting and had questions to answer, which I really liked. And I can only encourage you today to use the chat, which has been monitored by the guys, and they interrupt me. Anybody can interrupt me if there is a question, because it's sometimes a bit also for me, let's say, you just go through and waffle and it's nice if you get if I get a feedback too. So now for today, what I want to start with is talking about summing, and then we're going to talk about processing. We could talk about the products, but also about the technologies behind. That's a bit of a recap of what we did. I don't know, was it the second session or the first session, where I shared a presentation on Transient Designer and Vitalizer, how that actually works. I will do that a little bit later. So if you already saw that and you say, okay, that's boring, that's fine. But if you want to do the recap with us and have a question since then about it, then we can talk that through. I also understand that there is a bit of interest in when are these products applied in the signal chain, and how do we so taking a look at not just at the products but at the way of production, and that's something that I would rather like to do in the chat with you guys. Okay, so for now I will activate the chat here myself so I can see that. I'm going to share my screen over here, my second screen. And I hope that all of you are now seeing the Mixdream. Is that correct?
Yep.
Yes.
Okay, fine. So let me just open this window here again, because that went away. Okay, the funny thing is when I share, I cannot see the chat. So you have to monitor that, guys, and help me. All right. So yeah, mixing, analog mixing, analog summing.
Guys,
if you can mute your microphones, that would be great.
Thanks a lot.
I did.
Thank you.
Okay.
I'm managing the mute thing.
All right. Well. So analog summing. Well, just a bit of waffle up front, because summing is, let's say, controversial. There are many who really enjoy it and love it, and there are those who just say, I don't get it. Digital summing, where is the difference to analog summing? Or what is the difference anyway? Why summing analog? What? So yes, I mean, we can read, and you probably all have read about it, and you heard opinions about it, and there is some how can I say this? For I
Mixed
think that there are
opinions?
mixed opinions about what analog summing actually does differently to digital summing. Now, my take on it is based on information that I received from people who worked or who produced the algorithms for Steinberg, for Nuendo, for Cubase, and the mix engines for those applications. And the discussion was about how does digital mixing actually work? And the big difference is, as we all can imagine, is that we in analog, there is everything happens simultaneously, and in digital you have a separate framing that is not simultaneously. So the guy who actually produced that or programmed that mix engine said there is imagine you have like 48 or how many channels, and you need to bring them into 2 channels. And now you have all of the 48 tracks have individual phase responses. But in the mix engine, suddenly you have a framing determined by the sample rate, and the mix algorithm has to decide whether it's going to put that information into the current sample or into the next. And that decision has to be is difficult to make, because where do you set the time frame for slipping it into the next? And he said that was really there are different ways of doing that, and that is why a Pro Tools mix bus sounds different from a Cubase or a Nuendo or a Logic mix bus. They just have different algorithms. So basically, the higher the sample rate becomes, the lesser the problem of the next sample, because there is always an in-between sample already so that you can use. So the framing gets finer, and the difference to an analog summing becomes lesser. But let's be honest, we're in pro audio production, we're doing sample and double sample rate. Who is actually doing multiple sessions on the channel count that we today have in quadruple sample rate, or even more than that? That's super rare. Maybe with the advent of new computers and better processing, and this is becoming lesser of an issue. But for now, it is an issue, and you can imagine when you compare digital mixes, that you notice that for the general thinking is that Steinberg has one of the best sounding mix engines, and Pro Tools is not that good, and Logic is even not as good as Pro Tools. That's a general perception of what people say about it. Okay, fine. When you think about that, the sample rate issue and the question of how this information goes into this or into the next sample sort of determines about the how the individual phase responses are diminished, and the individual instruments come to you at the same time, more than they would be in the analog domain. In the analog domain, all the slight differences are all there, and therefore you get a much deeper sound stage. You get a better differentiation between the instruments. And in the digital domain, you pretty much have that feeling that it's rather upfront. Pretty much everything is rather upfront. It has its beauty, because if you want to go right up in your face, that helps you doing that. Whereas analog keeps it a bit smoother, but there is a downside to it, because suddenly this is all here right on the front, and the layers behind fall off pretty rapidly in perception. And it's hard to listen into the depth of a mix. In analog, that's very easy. Another thing that that people comment upon the difference is when you mix in digital, and you probably have had similar experiences. You touch a fader and you bring down the level by only 1 or 2 dBs. And then you think, that's too low now. It falls into the mix. I don't hear it anymore. No, keep it there. So the range is rather small. And then you give those people an analog desk and they touch the fader and they can move the fader by 10 dB and still the information is audible. And you go like, what? In digital, this would have been gone. I wouldn't hear it anymore. In analog, hey, here it is. It's still there. It's slower in level, but it doesn't fall away. It is still there because the masking is so much less in analog mixing than it is in digital mixing because of these processes that need to be applied there. Okay. Now, the product that we have that is one of our currently that's the biggest summing device that we have is the Mixdream. We designed this almost 19 years ago already, so that was pretty early in the race of the let's say it was the first wave of analog summing. And at that time it was even more important than it would be today. Because of the power of computers at the time. There were not even dual sample rate productions. They were all like single sample rate productions, pretty much. And everything that even went to DSD was done in Pro Tools in single sample rate. All the back catalog remastering at the time that was done for Super Audio CD and stuff like that. So the Mixdream. This is a 16-channel device, and what we did at the time, or what we figured out, and this is something that differentiates us from how other companies do summing. We quickly realized that you need to increase the rail to increase the headroom, because if you don't do that, you cannot sum 16 channels at full level. Your output will just be overdriven and clipping. Now, if you don't do that, and we're pretty much the only one doing it like this, we are the only ones, our competition is diminishing the level of each input by at least 6 dB. That is to prevent that the summation of all is not exceeding the maximum headroom and thereby distorting. But obviously when you do that, you lose 6 dB of performance, of signal to noise performance all the way through for every channel you put in. So an audiophile solution this is not an audiophile solution, I might say. We also did a product later to which is can you see that the Neos console, which is the silver one over there? If you can, can you see that still? It's not. Let me just stop this. This console over there. Can you the silver one?
Yeah.
This was basically we designed this one to try how mixing would sound like if we go from a 60 volt rail, which we have in the Mixdream, into a 120 volt rail that we used in the Neos. And we also added 8 more tracks. So these are all just 12 stereo tracks and faders. Yeah, I mean, measuring is one thing. I know that measuring, yeah, it's measuring data, but when you take an SSL console, let's say a G series, for example, and you put up one fader and the master fader at 0 dB, you pretty much get a signal to noise going on that is at 83, 84 dB minus 83, 84 dB. And if you add more tracks to that, the signal to noise shrinks. And so we wanted to know what 120 volt would do with that. So in this console, for example, we took 16 channels at 0 dB, master fader 0 dB, and we had a signal to noise of over -100 still. So that's how quiet the mixing can be if you would do a mixing console in a 120 volt rail.
I know what these
People were asking us a lot about, hey, can you make a big console? And with that would be astonishing because it wouldn't clip nowhere in the console. Yes, we actually were thinking about doing that. But our company is not really set up to build big consoles. That is such a nightmare to do. And I admire companies like Focusrite back in the 80s and Solid State Logic and Neve, who were capable of doing that. And I've seen the plants where they do this, and it's just a huge manufacturing process, and it's an extreme amount of money that you need to throw at it to get this going. So we said, now this is pretty much where we feel comfortable with. Everything else would be just we would have to build new buildings to start doing it. And who would be our customers at the end of the day? So it was a feasibility decision not to pursue this furthermore. And also today you can buy used Neve consoles, used Harrison consoles at good rates, because people just sell them for little money. So the discrepancy was getting really big. Okay, let's get back to the Mixdream for a second here. And I quickly run you through what you can do with this and what's different. So as I said, that the rail is plus and minus 60 volt, plus and minus 30 volt. So it's a 60 volt rail. It's a discrete class A design. And as you can see, we have 16 inputs up here that you can activate. And you can activate here, you can insert individually for each of those inputs. And you can, excuse me, oh, sorry, I need to drink a bit. Oh, that's better. Insert is something that you rarely find on these devices, and you need to have a full active design to do so, because you're receiving something, and then you have to you have to send it out again and receive it again after the insert, and you cannot do this passively. Oh yeah, by the way, passive. You know that there are passive summing devices as well, and the word passive to many people has a positive note to it. Yes, it does, because passive EQ is a cool thing, but everything else passively has negative side effects that people usually don't know. I understand that the hi-fi community is raving about passive because they don't like electronics. So less electronics, the better. But in our environments where we have to deal with huge amounts of channels and we have to bounce them and get them into other devices back and forth, it's just not happening on a passive summing or in a passive way. You need to buffer, you need to keep the impedance under control. And the impedance is the big problem when you do a passive summing, meaning that if you passively sum channels, your overall output level drops with the next unit, with the next channel you sum passively. So pretty much when you sum 16 channels, you end up at minus 30 dB of output gain. So the opposite happens to when you do it active summing, where adding 16 tracks actively could lead into a peak and into a distortion. The opposite happens in a passive way of summing. The output level drops by almost 30 dB. That's because the impedance of each input is adding up. And while you have more impedance, well, you have less output level. That's what you have to do then. You need to put a microphone preamplifier at the end. And some of the products don't have that internally. They just say, okay, use your mic preamp, and then you put that signal into a mic preamp and get it up to 0 dB again. So to me, or to us at SPL, that was never really an option. It was a relatively cheap way of doing it, because it doesn't, you don't even have to use a power supply, only for LEDs if you so want to illuminate them. But you wouldn't need a power supply in a passive summation.
Hermann,
All right.
I
Yes.
do have a question. That says, so do mastering engineers clip their summing devices to achieve more loudness?
Not necessarily. No, I don't think that they do that for the reason of getting more loudness. The reason in mastering is more a question of bad mixes. Sorry to say that, but we've been seeing more and more, let's put it like that, people who are not that educated as mix engineers making recordings. The record companies don't always enjoy the mixes, and they want to have the mastering engineers to look over it. But the mastering engineers then say, right, if I do that and I get a stereo track, I cannot influence the mix. I cannot make the vocals louder or the backtracks or the drums. I cannot adjust those. So what has become, I wouldn't call it a trend, but what has become a way of working around this is that the studios are not making full mixes. Maybe they do just as a rough mix, but they are giving stems out to the mastering guys. So they got the main vocal stem. They got probably a stem on the drums, probably with the kick and the snare separated as mono tracks, and they got the pads, the layers of synths and the guitars and so that they have like individual stems that they can mix together, and then it's convenient to have an analog summing device that actually brings all of that together. And that's where, as far as I know, they are mostly using it. But as I said, there may be different application, but that's the thing that I'm hearing. Does that answer the question?
I'll tell you.
Okay.
if you've got any reaction.
Okay. So now on the inserts, yeah.
Yes, it does.
It does. Okay. The inserts has individual on and off switches, and there is one switch that we have here, which is called no mix. Now, that is something that has a practical background. These units on the rear panel, you will see that they have all they are using DB25s. Obviously, because otherwise you cannot get all of the tracks in and out. So you can see here you got your inputs 1 to 8 and the channel inputs 9 to 16, and you got the insert sends first 8, second block of 8, and you got the insert returns. You got the direct outs, which is pretty unique because with this unit you can use this in a slave mode, and everything you put in has a direct out, so you can use that anywhere else, or you don't even you don't lose all of the stems when you integrate this. You have a stereo output that is analog summed, but all of the tracks are still available as single tracks after the inserts. So the processing that you've been done is here available for every channel single, individually. And that is the thing that is very helpful if you're not doing this as a summing mix at the end, where you have all the tracks recorded. Think of it, you use it differently. You take your mic preamps, and your mic preamps become the inputs. So during recording, you use the inputs, then you can process the kick, the snare, everything you want to do, and take the outputs. And now these outputs go into the workstation. So you have individual 16 tracks from analog preamps with the processing. Now, think about the situation that you are you have like certain tracks here that you don't want to be mixing down. Let's assume you just want to mix down the drum stem for the and make it and create a drum stem, but you still need to listen to the entire mix, and the entire mix would get into channel 1 and 2. For an obvious reason, then you can switch 1 and 2 to no mix, meaning that you hear them on the monitor chain, but on the recording output, let me go back to the rear panel, on the monitoring, you will still hear your mix and the stem, but on the master output, you only have the stem. So you can record that as a drum stem while still listening to the other. Imagine you can do this for anything you want to do. If you overdub stuff and you can just tell each individual track, no matter which one it is, to not go to the mix. That's a huge help, especially when you have DV25 connections, where you cannot just simply take an XLR of an individual track out of it. So, and that was actually the reason why we did this. Then we have 6 channels, channels that can become mono tracks. Now, why is that interesting? Well, if you think about it, if you think about it from the perspective of a converter, the converter that follows after is always a stereo device. There is no such thing as a single converter. Maybe in super high-end devices they do that, but not in multi-channel devices. Avid doesn't do it, RME doesn't do it. So all of the companies, and Lynx doesn't do it, who do these interfaces, they use stereo converters, meaning that if you want to position an instrument, let's just, or the lead vocal, the bass, the kick, the snare, these are 4 of the main instruments that are dead center in dead phantom center, usually, right? Now, if you want to place them dead center, you need to, without the mono function, you would have to pen them center in your workstation. So let's say kick and snare are pen center on the workstation, and then they leave on channel 1 and 2, and you have on 1 and 2, you have both information, kick and snare. That's like a stereo stem already mixed using the digital mixing process. If you want to avoid that digital mixing process and you want to keep them really individually, you need to pen the kick, let's say, fully left and the snare fully right. Thereby, your converter is using the left side of the converter for the snare and the right side for the kick. Now, when you go into a summing device, suddenly your snare appears left and your kick appears right, obviously. But then that's why we have the mono function. You switch this to mono, and then you have them analog mixed into the phantom center. And that's different sounding to doing this the traditional way on the digital side, where you already mix them together there. So that's why we have 6 channels here. Usually, you don't really use more than 6 channels that are dead center in the phantom. For the rest, they are stereo stems. We also have a general switcher for all of the inserts that are on there, just to switch all of them off at once, which is kind of a good thing if you also, when you go into troubleshooting and stuff like that, where things do sound awkward at one point, before you just undo everything and then don't recall what actually was on and off before, you can do that, and you simply see that. But it's also kind of cool when you do that and impress your customers. Listen here, I got all my analog equipment, I'll switch it all off now. This is your see, and that's what I can do, switch it on. There is an expansion input switch as well. So you have 18 channels. Well, but the expansion doesn't have the inserts, but it's 18 channels basically. You can use another Mixdream before that, or we have like the Mixdream XP, which is the expansion unit. This one, we talk about that briefly later, that you can use for that. And after this is now all being summed together, we have like a two-bus processing chain down here. The first one is a master insert. So here you can insert, whatever, a compressor or whatever you like to insert for that stem, with the send level switch and an insert on-off switch. You also get indication of the return signal, so that what you send out is really coming back to the unit again. You have a stereo expander in here, also based with a switch, and it has 6 positions, and it spreads. It's an all-pass filter design, so that's really for many people, one of the favorite expanders they use. Then we also have a peak limiter, an analog peak limiter in here, where you set the threshold with this switch, and then yeah, you can sort of protect your AD converter that follows after. And you have an output gain plus and minus -3 plus 2 dB, so a fine setting in 1 dB steps. And if you so wish, you can engage a transformer. There are standard in there, and it's a couple of transformers for stereo, obviously. And you can engage that and listen to what the transformers do to the sound with or without. All right, so let's take a look at the rear panel again for a minute. We spoke about all of these. Now this one is a special input. This DB25 holds the master insert, so the send and the return, the expansion input, as well as a second master output, out2. And for this one, you need to have a special cable. It's not a straightforward DB25 to XLR. It is still that, but it has 4 males and 4 females. So usually that's exactly what you would use for a digital, on a digital snake, where you have like 4 male and 4 female for 8 digital signals, send and return. You can still use those because the impedance that is important for digital signal, let's say the 110 ohms on AES, it doesn't really affect the analog audio, and you can use them for analog audio the same way. That would be cool.
Hermann?
Yes.
I do have a question about something that you said a little bit earlier. The question is, how does it increase width? Does it boost the side channel?
No, it doesn't. It doesn't boost the side channel, because that would be as if we would have an MS in there, where we are taking, where we make a mono and a side signal out of it, and then we make the side signal louder. No, this is an all-pass filter design, and that pretty much takes the off-center signals. It makes a differentiation between left minus right, and then the difference of that is being sent to the opposite channel phase reversed, and thereby you get that spread, perceived spread of the stereo width.
Hermann, if I may, so when we started this, you told us, the digital side of things, the summing, it is very 2D. Everything is upfront, and the analog has that depth, which I'm not debating. But what we've been taught, or what the general perception is, digital is fine. Digital is right, as in what goes in comes out. But analog has this non-linearity that gives it the width that we're talking about. But so I think that's what they're also trying to understand with the increase in the width, or how the exact process happens. That is the ideal you would ask us to work in.
Wow, honestly, there was a part of it that was interrupted, and I didn't. Can anybody help me? Because I couldn't get the question really. Was it only interrupted for me? I'm sorry.
No, it was interrupted for me as well.
But
and I think it disappeared.
Yeah,
it froze.
I'd like to add that. He was saying that
the general question was, how does analog provide depth, so to speak?
Yeah. When he said that, we have been told that the digital is correct and analog has that non-linearities to it that makes it sort of non-correct. I do not subscribe to this opinion, and I also do not subscribe to the digital correctness. Fact is that digital has, by sort of chopping audio into pieces and then putting these pieces together, and all the algorithms that are in between, it does a lot. It affects audio a lot. And it is and in all different ways. That's why all the workstations sound different. So that's almost like consoles that sound different, maybe in a lesser obvious way, but that digital is perfect and analog is not, if I may say so. And that digital has this analog gives the non-linears with which makes some effects that may then sound good. Honestly, analog was there long before digital was there, and the analog sound is to many, if it's done right, superior and more natural than many of the digital mixes. Obviously today there is lesser money in our world, and we need to deal with lots of tracks. I mean, today we have an inflation of tracks on the workstations. I mean, if you do film, I know people that run 1,000 tracks in a film, and everything, every little jingle, every little thing gets a different track. So we have this huge inflation on usage of tracks, which former days when you had like a tape recorder or something, you were pretty much restricted, and you need to understand where you put what. And you use tracks for many instruments if they occur subsequently. So you don't use a new track for that. And before that, like in the Beatles days in the 60s, where there just bounced tracks after track because they only had 4, there is some beauty in all of that, because there is so much thought goes into when you record what kind of instrument. I'm not necessarily talking about the overall quality at the end of the day. I'm just talking about the way that people made their mind up and thought about how they are going to approach a mix, how they are going to approach the channel counts, and their processing equipment, which was all limited. Today, open up 1,000 transient designers, do it. You can. But that kind of an inflation of using things lends us to believe that we can do, it's all good, we can do anything we want, and we have everything here, and now I can do this later, and I do this now. I have a digital correcting piece that corrects my vocals because they were shitty, but it doesn't matter, I have that. So we sort of go into a stage of, okay, I put it in a different way, because in one of my the guy who's doing our live shows where we play with the band, he has always the same thing to say when this was he says, when he's been asked, hey, can we do this this later, can we do this later when you mix? Hey, this is a mixing desk, it's not what does, I need to look this up, Kläranlage, which is, how is the English word for, sorry, that spoils the joke, but the word for Kläranlage, this is the sewage plant, is that the right word for it? Yeah, it's a mixing desk, not a sewage plant. And he's perfectly right with that, in my opinion.
I think I think the digital age just doesn't have has commitment issues everywhere, personal life, in mixing, everywhere. We just don't commit to anything at this point.
It's true. It's true. And when you talk to those people who really do it for a longer time, and who may have their education back from the days when there weren't those things possible, they are pretty much in agreement that making decisions very early in the process is key to a good mix. And I was just recently listening to a 1.5-hour seminar that Brian Eno did, and he was talking about the same thing, about that nowadays we think, yeah, we record this. No, we don't put any compressor on it. No, we don't put any EQ, no de-esser. No, all clean, and leave a little bit of headroom, and just we can do everything else later, right? So, because are we shy of not really doing it right from the get-go? Are we not capable, in the worst case, of making a judgment, a decision? Oh, that's better. Leave the compressor on. Oh no, that EQ was cool. Leave it on. Now we probably need to bring this up a bit more. Do it, and record stuff like that, because later in the mixing process, you have too many variables. You can change everything around, but that actually means you didn't have a clue from the get-go how it should sound. And that is the main problem. If you don't have the recording in your head, don't start doing it. Good book on Al Schmidt. He was talking about the same thing. And I can only say, guys, get this book from Geoff Emerick. He was the guy doing the Beatles. From 62, he was an assistant at Abbey Road, and from 65, from Rubber Soul, he engineered all of the Beatles records together with George Martin, but he was the guy on the desk. And they pretty much broke all of the rules that Abbey Road had. It's here, there, and everywhere. It's such a cool read from a guy who just recently passed away. Sorry enough, but I was fortunate enough to get to know him on a NAMM show. Super shy guy, like a British gentleman who is very low voiced, and he was, you don't really get an opinion from him about something because he doesn't want to be opinionating and talking to people. He was so shy. But one thing that I recall that he was saying was about mono and stereo mixes on recordings. And he said, you know, I'm so fed up with listening to the Beatles remasters and all of the so-called stereo records where they had like A-B. I thought it wasn't even stereo. It was just different information on snare and drums over there and guitar over there and one local over there and the bass. It was just left and right A-B stereo. And he was so annoyed about that because we put so much effort into creating cool mono mixes at the time. And we worked on that so hard. And what turned out to be, now you can listen to it. It's not the mixes we did, but this is the most popular way of people listening to it. And it's just, honest to you, he said, this is just shit. So I was really impressed by that. And I got myself, last year, I bought myself the Mono Masters vinyl from the Beatles. It's a triplet vinyl over there. Yes, and it's a different ballgame, guys. And you listen to the original Mono Masters and you go like, yeah, that's really good. Well, anyway, it's a bit off topic, I have to, but it's just me.
Now we have a remark there that says that nowadays even microphones can be changed after recording using digital plugins.
Yes, Mr. Slate, hello. Yeah, Stephen Slate, he's a guy. Yeah, but again, what does that say? It's the wrong way, full stop. It's just the wrong way. We need to trust ourselves. We need to trust our hearing. We need to trust what we think this recording should be all about. This is the main thing. And guys, make up your mind in the first place. Then you select the microphone that fits that purpose, that fits that sound that you have in your head. And then you do it. And right, okay, I give you one story from Al Schmidt. And this was from a recording session 3 or 4 years ago in Switzerland, where he was doing a seminar and we were co-hosting that seminar. Who else was there? It wasn't Ed Cherney, but George Massenburg. Yeah, he was there. And Al, I mean, this guy died in the age of 91, and he started recording in the age of 7 or 8. Well, that's when he started to work with his uncle in New York, who had a recording studio, and he spent all of his days there. And with the age of 13, I guess it was, he was alone in the studio on a Sunday morning, and nobody came in. Suddenly, the elevator opened up, and Duke Ellington came out of the elevator and said, "All right, guys, here we are. Let's go record." And he said, "I was alone, 13 years old." So this guy recorded Duke Ellington alone when he was 13. Wow. It's just, and with, I mean, in 1943. So he knows microphones. He knows microphones, but he's just not just knows microphones. He knows the serial number of the microphone that he uses for Frank Sinatra or Barbra Streisand or whoever. He knows the serial number that goes best with that vocal. So this is what we all lost. We just pick something. Yeah, it's an SM57. It's whatever it is. This is the U87. This is an M50, if you so get one. And you think they're all the same? No, they're not. And you can exchange them later on digitally. Sorry, guys, but that's just funny.
Yeah, because you have the mic, but you also have the position of the mic.
You have so much more, and you cannot render this, right? You render something average of everything, and it's sort of like, but it's never the real thing. And we have to be clear about that. There is no second guessing on this. But it's, yeah, but you can sell this because it makes you believe, oh, now I have everything at my disposal that all of the big guys have, which I can never afford in reality. But honestly, you probably don't have a clue what to do with this. And also, then he was recording this session in Switzerland, and he was walking into the room. They had a little ensemble of like 5 classic musicians. There was a piano or a flügel, a piano, a double bass, and a small drum kit, and a vocalist, and the acoustic guitar player. So they were like jamming there, and he was going in, he was doing his thing, talking to everybody, making everybody feel comfortable, giving the session a smooth groove, giving everybody, pleases everybody, setting up the microphones, selecting the microphones, positioning the microphones, walk out. He went to the control room. He set all of the faders on the desk to 0. He set all of the mic preamps, and he used our Crescendo 8 at the time, all like, as I said last time, he set it all to 12 o'clock, didn't touch it. Everything was straight, and he listened to it. And then he walked out again, and he took this other mic, moved that a bit, asked the double bass player to go 50 centimeters further back, reposition stuff, and he went back into the control room, and he stood there and he said, "Okay, done." Suddenly, one of the guys there was saying, "Hey, that's it? That's it now? Don't you need to apply EQ? Don't you need to compress something? Don't you need to work on it?" And he turned around to him and said, "Is there something you don't like?"
Insane.
Yeah. Take that approach, and it really taught me a lot. I was just goose pimpled at that moment, and I was like, yeah, right. You don't have to use all of that stuff as mandatory. And he was one of those guys who never had this equipment at his disposal when he learned how to use it. I mean, he literally learned everything. I mean, think of it, when you start in 43, and in the end he worked with the biggest desk and the biggest Pro Tools rigs, and he was good at that too in the age of over 70. Yeah, he was one of those guys. Okay. My 2 cents on this. Sorry for the excursion. Right. it's so dry going back from these stories to the products. Forgive me. I want to, because we're already like almost an hour into the session, and let's just speed this up a bit.
KG has a note. He said, "I officially award the title of the word goose pimpled to Hermann."
Yeah.
For next sessions, Hermann, you
Yes.
should try to make us cry. You have 2 sessions left to make us cry.
Oh, really? Oh,
Go
I'm
for
not
it.
sure whether I want to try that.
Oh, you were that close. You were that close right now.
Okay. The Mixdream XP summing device. This is a simpler version. As you can see, it has the same amount of channels, also an input, so it's also 18 in 2. Basically, you can switch every of the pairs to mono, so not just the 6 as we have it on the bigger Mixdream. On the XP, you can do that with everything, but you don't have inserts. So this is just a straightforward design. You have 16 channels going in. These are the expansion inputs on XLR, monitor outputs, and main outputs. Very straightforward. But people usually buy it as their expansion to the big Mixdream. But I know many who just use that because they don't have analog equipment to insert, and they don't need the processing in the stereo bus. So they're just good with that. And from the price, it's awfully much cheaper, but it has the same rail and the same discrete Class A op amps. So from the technology inside, it's totally the same, and the sound is also the same. Okay, now we're going to the processing part. And I want to start with one of the old products. And I think the de-esser, we had this last time when we spoke about de-essing in the channel strips. And I was giving you that story on the recording session where this was actually being designed by Wolf, my friend and partner and co-founder, overnight, when we had the session with all of these, I don't know, 15 or 14, 15 people from all over Europe, and they were like doing overdubs in different languages, and we had problems all over, and we couldn't handle them with the traditional way of de-essing using a band compression. So what we did here, or what Wolf came up with pretty much overnight, a detector circuitry that allows you that hones in on a frequency that detects the S's, so it could really detect noises. And yeah, we effectively this device has only one pot, and that pot is feeding the phase inversed S sound back into the mix, and thereby this device, yeah, cancels the S's rather than applying compression and just diminishing the level of it, but by using compression, the S gets squashed, and then you get those three effects on it and stuff like that, which is not really nice, and you don't have these side effects when you use that. So that was actually designed back in 94 or 95, so a long time ago. Also had that feature male female. It was just the search frequency area. Male is a little bit lower, female is a little bit higher, so that it could easier detect the ranges. And it has an auto threshold function, which was designed to keep the amount of de-essing constant at the output. And by that, we overcome the problem of bad microphone technique. And that somebody who's moving closer to the mic, suddenly the S's become more apparent. But that means that we increase the de-essing process, whereas when he goes further away from the microphone, the S's do not be that loud. So we don't, we do less mixing back of the phase inverse signals. that was really a big thing at the time, and a very well selling product. And over the years,
just Herman.
Yeah.
I'm sorry. I just have to interrupt you because the questions are a bit delayed regarding your speech. I do have a questions about summing again.
Oh yeah.
So that's the question. Being a dance music producer, I don't deal with a lot of analog recordings. So how can a summing device level up my game?
Yeah, well, that's pretty much the same thing as how Mike Dean, he's doing all of the Migosh and all of the rap guys he's one of the most known rap mixer, and he has a big Mixdream, but he has no processing inserted. The thing that he is saying is just when I mix into that box, I just have that better separation and depth that I get from all of the stems and all of the signals that I'm throwing at it out of my computer. So he does pre-mixes, stem mixes on the computer with all the pre-tracks, and then he sends the stems out, and the final mixes from the stems that's coming from the Mixdream. And to him, he says that's my go-to thing. That's part of my sound, and that's he loves that. And there's a lot of people who actually really dig that. But I also know people who say, well, I don't. My digital mixes are fine, so I don't want to use it. I can see that, because you have to keep in mind, you need to do AD-DA conversion. You make DA for 16 channels and an AD for 2 channels. And it stands and falls with the quality of your converter. So if that's not a good one, then you lose sound somewhere else. And honest to you, this is also about cable quality when you go for these amount of channels. And there is a difference in cables, and we can talk about that and the experiences we have with cables, if you like. But that is something that we also should consider. And bad cables do diminish the effect as well. And I've heard all of that. So it's all valid. There's no myth attached to it. Does that answer it?
I guess so. I do have another question for the de-esser now. The question is, in de-esser, what's the active button for?
Switching it on and off.
All right. Yeah.
It's like a positive way of saying bypass. So okay. I never like to bypass something and switch it.
We're used to bypass. So.
Yeah, but it sounds like heart surgery. If you want to have something in your chain and you want to have it working, activate it. So it's just the same thing. But hey, here, heart surgery. We have it on the. I use. Okay.
No, yeah.
I have to admit.
The person asking the question said that he thought that it has some other feature adding up with those things pressed. That's it. He was just thinking that it was adding something to it or to something else.
No. It's just on and off bypass. Right. Yeah. Good. But I have to admit, in my early days of working and designing the products, I was like looking for different labelings a bit too much to be different. And over the years, I calmed down on this, and I used the more general things that were, forgive me, it was just the youth. So, okay, on the de-esser, we have this as a plugin in a dual band version. As a dual band de-esser, but we also have it as a 500 series module as a dual band de-esser, which was the thing is that there is something that we call an electronically induced S. That means that when you have an S in your chain, the electronics that it passes through are putting a harmonic on that S, and you get a super high additional to it that is not in the original voice or in the original recording at the beginning of your processing chain, but at the end of the processing chain, this is suddenly occurring, and it's and you can see why that is, because that is every component has a certain total harmonic distortion, and if that adds up through a chain of electronics, then there is this harmonic S, which is usually around 11.2, 0.3 kilohertz. It doesn't really differentiate much in its frequency. It's in that area. For example, if you take the Black Album from Metallica, and you only and if you listen to that, you know exactly what S I'm talking about, because that's so hard on this one. You only need to apply the high S reduction, and it sounds better. It really does, a lot better. So this is doing the upper harmonical S, whereas the low S is exactly the same as what we have on the other product. So this does the low S in the range of 3.5 to 5 for the male setting, and for the female setting, it's about 4.5 to like 8 kilohertz. That's the range the detector looks at. And then it hones in on that frequency, and we copy that, phase invert it, and feed it back. And thereby you cancel it. And SPL this is only how we do it. There are many DSs on the market, but none of the others work with that principle. Okay, I like to go over to the transient.
Herman?
Yes.
I do have another question.
Yes.
What are your thoughts on manually lowering the volume of the S's before it hits any chain with a volume automation?
Oh yeah, I know that is something that people like to do, and that's also a good way of doing it. If you get a good grip on that S itself to lower it, it's always a problem how to identify it. I know other guys who now do it, they really do get everything on disk, and then they start editing this manually, and they have their routine on how to look at it and find the S's, and then they just draw it and do it this way, because they don't want to have anything electronically in their process, in their recording chain up front. Most of them probably are not using. I mean, if I would do it that way if I wouldn't have this technology at hand. If I would just have like a DBX or something with the old way of compressing it, the side effects are there, and it's like a trade-off, whether you want to have the S or something lispy, and then it is pretty clear. Forget about this. I do this later differently, and the fader thing is one, the editing is another. But I know that if you use the phase cancellation mildly, not like dramatically, but you can do a lot. But let's say always like approach little things, never do too much at once, rather do one thing twice mildly than apply a lot at once. That applies to pretty much everything, especially to compression.
And there's a note by KG saying that, but the SPL de-esser really shines during recording. The volume automation choice you can do post-recording.
Yeah, that's true. Yeah.
And then Spar said, so that's the person that asked the question about the. Wait for it. There's another one before. Can spectral editing be a good alternative to it?
Yeah.
Okay.
There are ways of doing it. Absolutely. It's just about, again, how much do you want to do right from the get-go and never think about it again? Right? It's well, the way I see it, everything you need to do later takes time away, Oh, no, it consumes mental space because you have to remind it and doing it. And it's in recording, to me, the most important thing is spontaneousness. That you get, the artists are usually performing the best if they don't know anything about recording and anything attached behind that, if they can do their thing. And they're pretty annoyed when you're not ready when they are. So catching the moment is the most important thing to get the best performance, because they don't do the best performance when you want it, when you are ready. As an engineer, doesn't mean that they are ready, right? It's probably exactly the opposite, because they are annoyed and pissed off that you fiddled around with your knobs for such a long time and they were just like bored to, and yeah. So everything you can do easily right from the get-go, that's what you should do. You just know what you want. And that gets us back to what I said before.
And then we have another question. We do have already an answer, a written answer, but just for you to confirm it. Where do you choose to put a de-esser in the chain?
Right after the mic preamp.
Yeah.
First thing.
Yeah. Okay.
First thing. Because the S is actually triggering a compressor as well, or it is in a filter. If you would do EQ first with the S, you wouldn't have the freedom of enhancing the high frequencies without increasing the S's. And then a de-esser afterwards would have to do two things. You would have to do much more, whereas the one that you, and it probably affects what you like to keep as well. But when you do de-essing before and you get the annoyingness out of it, you have more freedom to apply high frequencies without getting these S's too loud again, because they are diminished in the first place. So for me, it would always be right after the mic preamp.
Supposed to come here and
All right.
Okay. So how is our timing? Because on the processing side, it's a transient designer and vitalizer that I was asked to give it a little, talk about, and I did this already when we talked about technologies. I think it was the second session or the first session. I'm not sure. How do you guys feel? Shall I do this again, or is that too boring for most of you guys?
I think it's just an extension of processing. It would be nice to hear your input of putting this in terms of summing. With this going into summing, like with regards to summing, how does this processing units help? And I think that part of it we could talk about. It would be interesting.
And we do have some reactions to your questions, Hermann, and some people want you to go ahead. So do it.
Yeah, I do that. And to your question, we have to look into this a little bit more differentiated, because what can I tell you when I say, well, you got a vocal and you want to compress the vocal? Why do you want to compress the vocal? Is that really then one of the questions that we should talk about, or is that?
I think they take whatever you give them. I mean, you're so interesting and you are so a good storyteller that I think that they are all ears. And I'm not joking, because I can see the notes and the remarks, and it's just like, yeah, go ahead. KG just said, man, you're such an amazing storyteller. So go for it.
Okay, well, thank you guys. Okay, then I go over here and I switch to that keynote thing, and I'm going to start that keynote, and I hopefully is that, can you see that, guys? Is that yes? Okay. So as I said, this was presented earlier, but I updated the date for the day.
Wow, we're professionals.
Yeah,
wow.
See, now I'm fucking it up. and it doesn't do what I want to. Oh, here you go. Yeah, so this gets us back on the Vitalizer. This gets us back into a time when we actually really were starting the company, and Wolf and I, we started this in 86. Now I have to say, Wolf started it in 83 already. He's like 7 years older than I am. And I got to know him in 86. And at that time, his first try of running a company with some other people didn't work out so well, and he was about to go out of business. And I was at university at the time, pretty boring economy study, and I was just like getting to know Wolf. And I was a bass player, still am, but I was in need of a preamp, of a bass preamp. So I got to know him, and I first thing, can you imagine? He was sitting in a garage. I mean, it was literally a garage, where he had his desk and his on the right side there was this glass type of, almost like an aquarium, but very narrow. How do you call this in English? When you use acid to get the tracks to get the copper away, so that only the tracks remain. I don't know how that process is called in English, but that's very, very annoying to do, and it stinks, and it's bad for your health and everything. So this was there, and then he had all his test equipment there, and there was another workbench over there, and I said, hey Wolf, you have this parametric equalizer, this 3-band thing. Can you make me an input for that on a, let's say for an instrument, for a bass? Because I need something like that. And he said, can you solder? I say, yeah, I can solder, but and also can drill, but I cannot get anything to work. That's not my thing. I'm not a boffin. Yeah, okay. So if you can do that, that's not a thing. I can design that on the board, and we make a breadboard, and we're gonna asset it over there, and then you're gonna drill it and stuff it, and I get it to work. So that was the first thing I got to know Wolf, and just the sheer fact that he was so nice and he just did that. I was just blown away, and he did so many different things, noise gate compressors and everything. At the time, can you imagine what he did was, we had the Deutsche Bundestag. That's a parliament in Bonn at the time. And he, with this little thing that he had, he equipped the Bundestag with, I think it was 62 noise gates for all of the microphones that were in the hall, in the parliament, for all the people who stand up and go next to their desk and then talk. So they were like all these individual microphones, and he did that. I was just like, what? Really? How come you get to know these people? So I was impressed, and then his business didn't do well, and not because of him. It was just because of his partners who tried to make the company known in Australia because they were known in Germany, and then it all went down. And I said to him, well, it would be such a bad thing if all of what you can do, of what you know, would just vanish for nothing. Now, I'm still in the university. I don't need any money, but I can come up here in the afternoon and we just try, and let's see. Maybe it works, and I will not go back to university, or it doesn't, and I go back and I do that. Turns out, yeah, 34 or how many years later, yeah, I still haven't gone back to university, so that works kind of well. And I remember that there were like one of the guys there in that company, when I told them that, yeah, well, we want to go and do our own thing and get Sound Performance Lab back on the map and rework it. Well, it's just Wolf and you. Say, yeah, well, we'll try. I say, oh yeah, good luck with that. If you don't have an invention that really is different, you will not make it out of Germany. Okay. And he was right to a certain degree, because at the time in the 80s, all of the processing that was done came from the US or from England, and it was just starting to come from Japan. And in Germany, well, we had microphones from Germany, yes. And maybe EMT with reverb plates and stuff like that. So very expensive equipment. Yes, that was existing. But Studer, the tape machines, they were coming from Switzerland. But processing from Germany? No. Nobody want to have a German sound. It didn't even exist. And it wasn't popular. I think we had Kraftwerk, a few, and that was pretty much what they thought German sound would sound like. So it was difficult. Anyway, so we said after this was in '87, I said to Wolf, hey, if we want to do something differently, we need to find a way of creating a product that is just totally different and gets us on the map and just gets SPL on the map somehow. And he said, yeah, how do you want to do that? I said, well, I don't know. I get this philosophy of treating audio as an entity, not as like, hey, I have 5 bands and I'm chopping up my audio and I do low band, mid band, high band, and I put it back together and then it's great. No, I just thought, isn't there a way of doing something, using it as an entity? You know, I was just like a bit on the flower power side of things. And he said, well, I don't know, we can try. And so he set up on his workbench, he set up a forest. I mean, literally a forest of electronic parts. I said, whoa, what is this? Well, this is a sub-bass filter, and it does this and this and this and this. And here I have a mid filter, and this is a Chebyshev. This is a Linkwitz. This is a what kind of, I don't know. And I have and this is stereo. No, it's all mono. All right, it's all mono. And how many? So we have like 7 pots, 7, 8 switches, and another set of 7, 8 internal trimmers or something, and mono. Now this is all I have, and we can play around with that. Maybe we find something, because I read in a book, he said, from Don Lancaster, and it was on his last page. Don Lancaster was a famous guy writing cookbooks for filters. And he said, last page, there are theoretically 2 million filters possible. 2 million filters possible, theoretically. In practice, probably only 2,000 have ever been built up. And effectively in the market and used, it's short of 10 different versions. So once you've been through this book, experiment. Just find the others. And he said, yeah, it's right there. That's the mantra. That's our mantra. That's exactly what I meant. We have to try. So yeah, okay, we have to try. But we were like, I mean, we didn't have any money. I mean, my father gave me the money, but we were just like living in a parent's place without anything. And so we needed to find a way of, how can we judge what we do, if that's cool or not? Hey, we cannot afford any good monitors. We cannot even afford an amplifier. We cannot afford good stuff. And I thought, yeah, well, okay, we cannot afford the good stuff. What is the worst? What is the worst we can listen to? So yeah, just put the plain chassis to the wall. You have all the negative side effects that you have. And so we bought 2 chassis, broadband chassis, for like 14 marks or something, which is ridiculous. It's like 7 euros a piece. So that's shitty. I mean, it was the bottom line. And we used wires and put the wires into the corner of the roof, into the corner of the room. It was really like that. It was as bad as, and you can imagine how that sounded. It was just crap. But I thought, hey, if anything positive happens with this forest of stuff here, it may happen on any speaker on the planet, wouldn't it? And Wolf said, yeah, we can say so. Okay, let's try that. So we were using the daytime for our regular job, work with SPL. I did my studies in the afternoon. I was in the company, and in the night, from 10 o'clock onwards in the evening up to like 2 o'clock at night, something, we were just sitting there and playing with this for like, yeah, I have to say, we were forced to do this because Aphex, you probably all know the company Aphex, who are famous for their oral exciter. We had this product, SX2, promoted in the Studio magazine as a surround exciter. I mean, it was a 2-channel exciter with a stereo expander. Okay, so and this was promoted there. And what happened was that Aphex got the excuse me, I gotta pull that off. Aphex got the patent on the oral exciter just 3 months before. And well, they put it out in Munich in the patent office. So you should be there every time once in a while and take a look if there is anything relevant to you. Well, nobody does that actually. So they were writing to us and say, well, you're infringing our patent. You're infringing our patent. And if you bring this up to the market, we're going to sue you. And we had the front panels that you see here, this front panel, we had this actually already been stamped. And we had paid 2,000 marks. At the time, this was a fortune for us. And the stuff wasn't printed, it wasn't anodized, it was just sitting there. But we had these panels. And now somebody was saying to us, if you put that to the market and you go to Frankfurt Music Messe and just show it, you're going to get sued. I was shit scared. I mean, it was fucking Aphex. And AKG was their European distributor, and you don't mess with AKG. So that's why we were forced. And then we had to like say, okay, forget this product. We're not going to do the SX2. We're going to do something else. And that's why my esoteric, yeah, let's do something. And Wolf started doing that. So it took us 2 weeks. In these 2 weeks, everything was just not really happening. It was, you heard all of this filtering before. It was just this, what you knew, nothing, but there was nothing really happening. But suddenly, and I tell this story all the time because it changed my life forever. That's the reason why I'm talking to you today, is because of that situation. So Wolf was walking around with, he said, okay, I'm going to take the sub filter output now, and I built this mix stage over here, and I got these filters being mixed in from here and there and there, and I'm feeding now this filter into that summing pot, and let's just listen what happens. So, say, go back, stop it, go back two of the pins. Take it off. That was a huge concert drum on a recording that we had from Jennifer Warnes. Once we take Manhattan, then we take Berlin. They had this recording, and I think this was the second or the opening track that started with huge concert toms. On our reference monitoring system, we just heard like, tuh, 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 tuh. And then he put this thing to the pin, and it went like, doom, doom, doom. And we looked, where does that come from? This is not coming from the speakers, is it? But well, what's happening here? It was 2 o'clock at night. So I said, hey, come on, solder it to that point, switch it all off. We come back tomorrow morning and we just see if it's still there or not. It was still there. From then onward, we tried to understand what happened, and we didn't. We just couldn't get our head around this. But then we were thinking like, oh, now we have like 7 pots, another set of trimmers and switches, but we only have a front panel with 4 holes for 4 pots and 3 switches on one side. We need to use this. We cannot throw this in the bin because we cannot afford to make new front panels. So we were sitting there and using the next 2 weeks to fiddle with this thing and to find a way of, hey, if we just take this one pot and we take another second level of another one. Do they just go sound cool if we arrange them together, or if they do like this movement? So we listen to music all the time, trying to figure out if there is a pot that only sound good on one position, fixed resistor, done. If there was like something that really did something nice, but the range was different, so different pot, different value, blah, blah, blah. So we went through this for 2 weeks, and finally, that's the reason actually why you see this awkward dual concentric pot over here, because we needed 5 controls and there were only 4 holes. So we just, okay, come on, we're going to make the output level the big one, and then we're going to make the dynamic ratio, that's the small one over there. And then we started to label it funny, because I didn't have any clue. I was just like, I never did something like this before. So there is a demask switch. This is just a process solo, but demask sounded better to me at the time. That was the very early stage where I tried to make everything different. Or let's say, no, I have to say, I didn't know it any better, because I didn't know about all of the other products and how they were labeling it. How could I? I never saw them. So I remember we were getting to a trade show. It was the APRS in London in 1809. And you see here, as penetration. Yeah, well, I didn't know what it meant. So I was on that trade show, and it was there, and suddenly there was a crowd of people gathering in front of this. They were all laughing. And I went, why are they laughing? I was just like feeling very, very uncool in the moment. So, and they were, and then our distributor at the time was Audio Design, Phil Bitet, and Phil took me to the side and said, "Hey, Hermann, did you really put penetration on that front panel?" I said, "Yeah. What does it mean?" And well, you don't. Well, I'm not 100% sure. My English is not my native. Well, we use this for like well, you all know right now. So and I went like, I got shit red. I was like, and I just wanted to flee that conference, because I didn't want to be the guy and do that. He did put that on, but the good thing is everybody spoke about it, and we were really hitting a mark with it, and it really created some sounds that were just not heard before, and this became a very well-selling device through the 90s. We did some other 3 years later, you can see it's no longer penetration. Now it's just harmonics.
Actually, Hermann, KG gave you another award for the penetration story. That's the Oscars. It's not a training anymore.
Yeah, so see here, demask becomes process solo, and it's an active switch here from in to active. There's progress. And dynamic ratio became process depth. So it was all like streamlined, and a sub bass, not a variation anymore. It had soft and tight because we had 2 sounds in there. That was really wacko, that you like turn it up to one side and you get like a soft bass, and you turn it to the other and it was tight and straight. How this filter that is behind this Vitalizer, later you see they had mastering devices and stuff like that, but it was like 14 years later that we received patents on it. The money I got from venture capitalists, and this was right before the big bubble, .com bubble died. I just got I think we received 1 million euros as venture capital, and this was I used to make the Vitalizer digital, and I could, because right from the get-go, I was thinking this is probably really a circuitry that is worth to get a patent on. But at the time when we designed it, we couldn't apply for a patent simply because there was no money. And then I was reading in the, at least in the German book, patent law, it says that if you don't make your development known to a regular professional, then you can still apply for the patent later, although you already sold it in the market. So I don't know if I translated this correctly. It was like law text, but later when we got the money for the funding, this was all right, because we took a part of the core and we put that together into a little housing, put epoxy around it, and so you need to X-ray it, or you need to cut layers off and get to the components and then start to rebuild this. But that is not what a regular professional would. That's more that's deeper. So that's beyond what the law said what you should take as a pre-measure, so that it is still not obvious what your patent is all about. As you can see, it's a hell of a filter, because and you wouldn't think of this when you go to the breadboard. Oh, let's design a new filter. Okay, let's gonna go and split that signal into 2 ways, and the one way, or we split that into another 5 ways. Yeah, great idea. And then we're gonna mix it together after it comes back, and into 4 ways that come into some kind of a sum of 4 things. Yeah, all into, and we, in fact, they're all, pros of them go to the negative side, which is, you don't do that. But this was just something positive happened because we did something without really knowing what we're doing. We're just experimenting. And guys, that is actually very important in terms of when you think about the difference between developing analog and digital. And I said this in the last session because I think it's so valid. With analog, you can just do funny things, and you just walk around with something and put a signal into something and just listen immediately what it does. Imagine you would do this in digital, and you would have to get the algorithm right that really mimics what you just did by putting that pin to that thing, to that IC and that pin. Impossible. There are weeks and weeks and weeks and weeks. So there is no such thing as surprise in digital. Digital development does not contain a surprise, because you have to know what you do, and you program it, and then you get it done. But in analog, I think when you think about this, true invention, something that is off for your mind in the first place, will only come from analog development, because there is the factor of surprise. You can just experiment and find something. And that's a big, big difference. So, and that's why we should never let analog die, because it will definitely take away the surprise factor in designing new stuff.
What you say is, everything that you say is raising a lot of questions, and what you just said relates to some questions. The first one is, how do I learn to build my own hardware? And then same person says, are there any good resources online to help me out so I can get started with building my own equipment? But half of the answer had been answered by saying, just experiment, just try.
Yeah, there is a certain basic knowledge, obviously. I still don't have that. Yeah, right. This is what the guys like Wolf or Bastian or Jens, all are the designers in our team. They know how to build, to work with the electronic parts. I have some knowledge about what these components do, but I'm not capable of producing anything that, where you have a decent outcome. I couldn't. What I'm good at is I'm designing all of the products. So how they look, how you operate them, where is which button do you need, so everything you see from an SPL product has been basically what I thought about. Okay, I want to approach it in a way that, one rule for me is always, you start from the left, you go to the right, and that sort of follows your signal flow, just as a basic thing. right? So on a channel strip, for example, you go from a mic pre to a de-esser to a compressor equalizer output stage, just roughly. So you go with the flow, so to speak. And designing your own products, yes, I mean, I think the DIY market is a very good starting point. There are just one of our guys, Sasha, he just yesterday, he finished one of his clones on a Pultec EQ. And it took him a long time to find the right transformers, and you couldn't get the originals, obviously, but those who got very close. And he just yesterday he told me about his comparison test on a real old Pultec with his DIY clone, and then the new from Warm Audio, down to the very cheap Clark Technics / Behringer clones of that, which are, yeah. And it was interesting that how close he could get to the original sound, but he was also like taking care about, hey, this power LED. I mean, these were these glass are almost like a centimeter wide or even more, with this red shaped hemisphere glass type of thing, and he got these original glass versions for him, so he was really into detail on it, whereas the clones now, they all have this in plastic. So no, it's going to be the real one. So he was sourcing it really from ground up, and he got the noise floor down to minus 90 dB, and that was a good thing. And the hum noise, the 50 hertz, which is always a tricky part in these kind of designs. Yeah, but if you start there, you get a basic, and you start with something that you can use for your production. It's already, when you do it right, worth a lot, because these products, you cannot buy them anymore. Nobody will make them really in that kind of quality, because the components do not exist in a quantity where you could run a series production on. So there's also a difficulties these days.
That leads to another question that we have. How that's more general, I would say. How do you usually come up with design ideas for devices, feedback from engineers to tackle a problem in the mix or recording, and then design the device ground up? And this person says, as I'm learning how to make digital plugins myself, I usually get stuck with ideas.
Yeah, the ideas thing is, yeah. Okay, the thing is, what do you want for yourself? Start there. If you have, and honestly, that's why we do it. Hey, wouldn't it be cool to have a tube compressor, something like with 120 volt rail? Oh, that'd be cool. That'd be cool. So you just think about stuff that you like for yourself. You know what I mean, when I look at it, I look at my portfolio of products that we already did, of niches where we are not present, of technologies that we have that they can fit those niches. Obviously, we do get a lot of input, and people say, hey, can you do that? Can you do that? But sometimes it's just like, they try to combine technologies. Oh yeah, a digital mixer in external with headphone amplifiers and mixes for live and analog this and here. And they try to put everything into one box, which is then not feasible to do, because you cannot mix all these technologies in one box. But there's also input where you go like, oh, I didn't thought about that. Interesting. Let's give that a second thought, and you start there. But honestly, 70% at least is what we want to have ourselves, and how we like to do it if we do that. Another different story was, for example, on the mastering consoles. That was totally driven by external engineers, by Ronald Prent and by Bob Ludwig, who had a need at the time to use analog monitoring and being able to not go through digital at the time in the 90s, where digital was changing week by week by week, and they different products. Now we can do like dual sample rate. Now we can do like 18-bit and 20-bit. Now 22. Now 24-bit. So that this is not the way we can work, because these guys usually have a lot of time until they decide to use a product in a production process. So they're not just grabbing a new product, oh great, and they apply it on the next project they do. Usually they parallel this for half a year until they're sure that they can use this for their client's project. And in that half year, they have 3 more converters or whatever monitoring devices in the digital domain with new upgrades and new features. So they never get behind them and said, stop that. We want to have an analog solution. Think of something that gets us to the point where we are superior to digital. And that led us to develop 120 volt rail, because that was the only choice of meeting the specs and exceeding the specs on digital by ramping up the voltage. I did some stuff on that. Well, this is on the website, but it's also on one recording station. I think it was the very first one. So yeah, the starting grid is your own idea. What are you missing? Do that. And if you're missing a parameter or something that you want to do, build it. Build that because you know why you want to have that. And why is it giving you something different? And exactly this is what you can argue later to others. Say, yeah, I did this because now you can do that. Oh, really? How do you think of that? I have the same thing. Never thought of this. Or I've never found it on another product. And this is exactly where innovation starts. Okay, let me just, yeah, that's the patent from Apex. Just from the complexity, it's a slightly less. They never sued us, by the way. Now, how does that actually work with the Vitalizer? And I run through this because I think we're getting late, don't we? For example, what this filter does, what we found out later, you can see when you can apply curves with this filter, and it's one band. This is a full spectrum filter, exactly as my flower power thoughts of treating everything as an entity would be. It was like that. And when you look at the curves of equal loudness, except for that bump down here in the very low frequencies, where we didn't want to rise those because you don't hear 20 hertz too well, and they do give a lot of energy into the power amps and soak off lots of power there. So that's why it falls off below. But everything here follows pretty much the curves of equal loudness, or so-called Fletcher-Munson curves. So adapting your mix to the way we are hearing on different scales of loudness, this is what the Vitalizer achieves, and with just a few controls. And another effect that it does, when we talk about audio masking, now usually when we talk about something that has a punch and a boom factor, and the boom is louder than the punch, which is then you suddenly don't hear the punch too well anymore. What the Vitalizer actually does, the louder the signal becomes, it puts a phase drift, but we're talking about a few 1.5 milliseconds. So it's not heard as a delay or something. It's also not affecting the phase correlation, but it's enough difference for our hearing to detect two sensations. And when we measured this, and this was like 2 or 3 years after we invented it, and we tried to understand, hey, why can we differentiate 5 symbols in that mix, whereas without, you think it's only 3? Or like vocalists or backing vocalists, for example. Now you hear individual voices, and we didn't think about that. But what we measured was that the louder a frequency becomes, the more it drifts in that time of perception. And when you use the soft bass, it falls behind. And when you use the hard bass, it's up front. We looked at the scope and we said, that's unheard of, because the phase response is not correlated with the amplitude. It's random behavior to a change of amplitude. That's what you find in the books, and not that there is a correlation possible. And we were like, is that real what we're seeing here? It would explain what we hear, but it's too good to be true in a way. So we looked at this and we tried to understand what it actually is. And then we were caught up, the guys from Fraunhofer Institute in mid-90s, they were just about to develop their own MP3 algorithm called, how did they call that one? AA3. That was the predecessor of their own format on MP3. And they wanted to know how to improve audio in low bit quality. So at the time, we're talking 64 kilobits. Biggest was 128 kilobits per second, but average was 64, so really bad. And we were invited to the Fraunhofer Institute. At least I went down there with Vitalizer and other stuff, and we tried Vitalizer on those heavy compressed MP3s. And man, they were like sounding totally empty, because what they were using in their algorithm is, if you fall below the threshold of hearing and there is an audio event that is supposed to be totally masked now when it's below 60 dB under another audio event, so they take that information out. They use that in MP3 to reduce data. And when you run this through the Vitalizer later, and the Vitalizer does its perception thing, and you suddenly hear that this information is apparent and audible in the non-coded track, and in the coded track, this is gone. And then I said, okay, we cannot use that, because it would actually reveal what you take away. And but it all, yeah. I remember that I was, Bob Ludwig was one of the guys who was mastering engineers who was using the Vitalizer, and as a mastering engineer of his class. So and you have to understand, in the beginning of the 90s, people didn't think of Vitalizer as being something, they thought that if you are a good engineer, you should not use these things. You don't use an exciter, you don't use a sonic maximizer, you don't use a Vitalizer, because we're trained engineers, we know what we do, and you don't have to have these helpers. And with that in mind, I was astonished that Bob uses it. And I called him up one day and I said, what are you doing with this? And he said, I'm using it on big band tracks on tape. So every time I have like a multiple of instruments, and let's say a big band with 50 people or something, and it's been on tape, I literally have no chance of improving the to hear more instruments, or to hear at least each instrument. There are so many maskings going on, and the recording wasn't perfect probably as well. But when I use the Vitalizer, he has the tube Vitalizer, the mastering version one, I can literally open everything up slightly, and you hear all of these instruments again. That's just my first step, and then I can pick and work on it and do my thing. So yeah, this masking or demasking effect on the Vitalizer is just still until today, I don't know, and we don't know how this really happens. And you have to understand, this is interactive. So you play a bass guitar, and if you hit a loud note that would mask the kick drum, for example, or the other way around, then the louder one is being shifted in phase just for that note, and then it pops back to the original. This is not a static approach. It is going with the music. The sonic maximizer from BBE, they actually do this in a static way. They sort of have the principle of using a three-way crossover. And they were applying, not to the crossover frequency, a fixed phase shift. That's how the sonic maximizer works. But in the Vitalizer, it's all adaptive, automatically adaptive on the spot, on the moment. And we don't know how that works, but it does it, and it keeps doing it, and we're happy that it does it. So what else?
To have that patent.
Yeah, yeah. But during the time of the patent, nobody really understood that. Even the company with that I was talking about, Uli's company, he bought, I don't know, various amounts of Vitalizers because he wanted to copy it. Couldn't. All right. Oh yeah, and then a few years later, the transient designer came along. It's one of our things that in the rest of the world, especially in the US, which started to make us famous or known, let's put it like that, in the US as well. And the transient designer was a design by Ruben Tilkner. And Ruben, you might know the company Elysia. That's his company. And Ruben was working with us until 2006, I suppose. And he was with us from 1996, I guess, for 10 years. And then he did his own thing. Yes.
Sorry to interrupt. I still have a question about the Vitalizer here.
Yeah.
Someone that is just curious. Why moved into the tube realm in the newer version available in the catalog than from the older version of Vitalizer?
We used two tubes in the Vitalizer because one is being placed in the mid-high filter section, and the tube simply sounded silkier and gave a more precious sound image there. And the second tube is used in the expander. So the left minus right added to the other side face inverse thing, that is done with a tube. And the tube has the nice benefit of creating an internal crosstalk of probably, like, I don't know, 50 dB only. That's the crosstalk between that. So that helps when you spread the stereo image to maintain a better phantom center. When you, the further you spread, the more unstable the phantom center becomes. And especially when you have a high channel separation. But with the tube naturally having less channel separation, it maintains a more focused center. And obviously when you run this hotter, it just sounds more forgiving because the tube is a nice and forgiving amplifier most of the time. Yeah.
Okay,
yeah. So Ruben, and he came out with this design one day, and he called it Kickman. and he came up to me and said, "Hey, Hermann, I have this thing." He's a keyboard player, so and he said, "I always want to do something like this, and now I have this. Would you want to listen to it and tell me if it's any good?" So and he only had like he used this he only had a attack and a sustain, two buttons, and I was like, "Oh, that's it? What does it do?" "I don't tell you, just fiddle and just take a look, listen." So I was attack, turn up the attack, turn down the attack, what the fuck is this? Said, "Yeah, try the sustain." And I said, do, 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 do. Okay. And to the other side, do, 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 do. This is cool. I've never heard anything doing this. What is it? Yeah, I call it Kickman. Okay, we're going to talk about that. And I can't tell you later we did this, but what I want to show you is I hope I have this here. All the different version we have as a plugin, as a rec pack module, as a module for the 500 series. But this is interesting. This is how it actually works. So what Ruben did, he actually created something that works on dynamics without threshold. So there is no onset where something above would happen or below would not happen. It happens all the time. The higher it is, the higher the effect would be, the lower the effect would be, but it's still always there. That was literally cool because that opens up a whole different set of applications. Now, what he was doing in his design, there is an envelope follower that follows the original amplitude. So you know the rise time, you know the peak level, you know the decline. And there is a second envelope generator that has a fixed and slower attack, or a relatively slow attack that would not really happen in reality. But you need this as a reference. And now you subtract the envelope 2 from the envelope 1. And what remains, the difference, is already a control voltage in millivolts, totally determined by the audio itself. Nothing set with attack and release is something that is fixed and you make the decision. No, it changes during the music is working. I mean, adaptively. And now you have this voltage that tracks and follows the precise way of your audio. And if you increase that voltage, it follows that shape just on a higher one. So you can take a waveform and you apply more of that voltage, which you do with the attack control to the plus side. You just rise that level and you get more attack. And if you're going to do the opposite and reduce that, you get less attack on any signal, on any. And then the same applies to the sustain. There is one that traces, in this case, it's number 3, and the other one that is super long, and you just subtract both from each other. And now you have a control voltage. You apply a higher version than this, or you apply this voltage, so you can effectively get reverb tails that are almost endless. So if you ever work on a reverb and you want to have, oh, this is too dry, let me do a bit more reverb. So you know how difficult it is to find a matching reverb, especially if you take natural reverb in the first place. So you fiddle for hours until you find the right one that matches the original. Take the transient designer, move up the sustain a bit to the right. Here you go. And you're done in 5 seconds, less than that. Or the other way around, oh, there is too much reverb on it. I need to dry it out. Yeah, you can. What can you do for drying? Noise gate. It just cuts at a certain left threshold where you set it. With the transient designer, you just go lower the sustain and it follows the original tail and just dumps the tail following the music. One application that we had with the Swedish broadcast. That was a funny one. So the Swedish broadcast had 30 odd local studios with single people making their local radio, TV, or radio spot, basically. And they were all sounding differently because they had all different chambers, different whatever. It was all a mess. And the Swedish broadcast decided we want to sound identical for all of the parts that come in. They should have the same ambient experience as if they were all sitting in the same room, although they are spread upon the whole country. So they bought in transient designers for each of the studios and used them just with less sustain, pretty much as a deverb. And then the total dry tracks went to the main broadcast station, where they applied one signature reverb for all of them. So that was how this has been, used in that application. I remember I was invited by this is now off topic, and let me just stop this here. We did this later. Okay. And I stopped the session for now. So we're back, right? Can you?
Yep.
We're back now, right? Okay.
Yep.
Oh shit! I forgot what I wanted to say. Where was I? It's good that nobody listened.
You actually stopped in the middle of the thought, so we didn't know what you wanted to say.
Yeah.
Yeah. You just ended with your Swedish story, and then you started something else, and never mind.
Any more questions? Anybody?
Yes, there's one question. It's an interesting
I have one.
question, a tricky question,
how
though.
is the Vitalizer jack different from the Mark II or the classic?
The jack was the most inexpensive version that we did for at the time. The biggest difference is if I recall correctly, it didn't have a drive control, it didn't have the bass compressor, it didn't have the harmonics, or just a fixed. It has a harmonics, but with a fixed frequency setting. It was fully unbalanced. And the Mark II Vitalizer had that additional drive control, which is, I think, is very important. And the tubes, obviously, the jack was totally solid state. There was not a tube in there. The stereo expander with the tube instead of the non-tube version in the jack. And compared to the classic Vitalizer, it was a stereo device and not a dual mono, obviously. In the beginning, we never thought that people would run full stereo through it, honestly. We just were thinking this is an onboard complementary equalizer to what you have in your desk as an equalizer. It's 80s, right? Think of it as being in the 80s. And it was then that the users were using it in stereo on their full mix through the 90s. And that's where we said,
is that how Bob Ludwig was using?
Well, no, he has the mastering version stereo.
Stereo, yeah.
Stereo.
It was on the master bus.
Yeah. Well, not on the master bus. He was using it when he was before he was transferring the tape to the computer. So and from there on he was working on it, but he was like transferring it, and then he was using that to have more differentiation on the sound image and more instruments and whatever to hear. Yeah, it was not later on the master bus. No, it was used before.
Okay. And the transient designer 2 and 4, they're basically the same thing. But one has just 2 and
Okay. It was also a money issue, and for the money issue, we also took out the dual version. I think. I know this has both unbalanced and balanced. I think we were thinking about a fully unbalanced version, but that was not really what we did then in the end. But it's a long time ago. But from what is inside, it's always the same thing. We didn't compromise that.
Right. And you said there is the tube version of the Vitalizer is silkier.
Yeah.
So and that's probably also the reason why it's more expensive.
Yeah, sure. These components are just I mean, tubes are really expensive these days. I mean, always have been more expensive, and you need to have a different power supply to feed them for the heating voltage and for everything else. Yes, it is more complicated, and that is also the price factor. Then, but I would always, I mean, my heart is with the MK2T, the single rack space one. I think that's really has the broadest application. The mastering version, you need to really know what you're doing, because that has a very different pre-tuning from our side. And if you're really into it and you know what you do, you can achieve wonders with this, but you can overdo it much easier than with the MK2T. If you're not that experienced, this will always come up with a great result. And you cannot overdo it so much. But on the the 2-unit Vitalizer, the old tube Vitalizer, this also has like the tube stage it doesn't have the tube stage in the filters. The filters are there built with coils, so they have their silkiness from using the coils. But the output stage, that's where we use the 3 tubes. There is one doing the left and right phase reversal, and the others doing, because in each output stage, you're reversing the phase so that you get in phase with the input, and all what you do inside is usually done out of phase. So it sounds more dramatic than it is. It's just that you, so the phase reversal stage is 1 tube, and then you have like the output amplification with 1 and the other tube. And there again, it's sort of that cross that you have 54 dB crossfeed typically on the tube, which is something that people really dig, because it gets them closer to the sound of vinyl. That has even less separate channel separation. I think if you can get like 30 dB channel separation on a vinyl, that's great. There isn't much more, but that's also when we spoke about digital and the realness of digital, right? In the beginning, initially. And now you think that if you have like 100 dB channel separation in digital, and you can do even more if you increase the bit rate, that is good. And it's not. Exceeding these specs and making them better and better and better is taking us away from reality, because finally, at the end of the day, we're listening to something. Now, we listen to nature, for example, just something natural. Now, tell me something in nature that we have learned to hear that is separated by 100 dB coming from the left side and 10 meters from the right side.
Yes.
It doesn't exist.
Exactly.
It doesn't exist. And for our hearing, and that how we learned to hear, how our brain computes what our ears are perceiving, and putting this together in a soundstage, a miracle on its own. How we learned to do that, that's what we learned from hundreds of thousands of years being humans, and probably even longer, because the hearing wasn't invented for humans. It is therefore like ages. And if we bring our hearing back, and we make a record, and we have stereo record, and we're going to put that to you, and you have 100 dB separation between your speakers, cannot be good. Cannot be good, because it's not natural. And so we have to always re-question or think about what is happening in reality. Is our technology supporting that or not?
The ideal from the reality thing. You also mentioned working with Ronald Print along with Bob Ludwig. Now, Ronald Print, I believe, was also working with people like Mutt Lang and Mike Shipley, and I think in the 80s. Right. So how was SPL doing in Switzerland? Because I think some of these producers were actually based in Switzerland, particularly Mutt Lang.
Ronald at the time, he was in Wisseloord, which was in Belgium, in Holland, sorry.
Netherlands, yeah.
Netherlands, and in Hilversum. And he did Elton John there and Police and stuff like that. They came to him. I mean, he was pretty much residential there. I'm not sure about. I have to ask him on Matt Lang. We usually speak. He's now in America, in Auburn, in upstate New York, with his wife Darcy, his second wife, and their son, and they're doing good. Darcy's doing a lot of immersive audio masterings, and Ronald is mixing for all kinds of immersive formats for Sony and in 360, and for Aura 3D, for his former employee at Galaxy, Wilfried. And obviously also a lot of Atmos stuff. So he's really good at surround mixing. He always was. He was one of the pioneers, and he's still one of the best guys doing it. Yeah. But I'm not so sure about his. I got to know Ronald in the mid 90s, late 90s, I think 97 or something. Since then we know each other. But don't know lots about his work in before that, and so I cannot comment on Matt Lang and Switzerland.
Yeah, but of course, you know, your session on Bob Ludwig was very helpful because Bob.
Yeah, but that was just
yeah.
But that session that was in 2016 or 15 in Switzerland.
Wow. I did have a chat with his assistant, Bob Ludwig's Adam Ayan.
Adam Ayan.
Yeah. So
nice
he
guy.
uses some of that material, yeah.
Yeah, he has a DMC the dual channel mastering console. He also has a tube vitalizer. He has the switch box, the insert box that we now have separately as the Hermes device. And he also has that a massive view over there. I don't know if you can see that. This one up here. We only built I think 6 of these because they were so expensive. Not our part, not that. It was the Yamaki meters that we have in there. We've been like, when we made the MMC1 mastering console for Bob and for Ronald, they were pinpointing us to this meter because it was the biggest meter with the biggest magnet, and it was just the biggest thing, and it was the best, and we should have that. So when we this thing alone, when it's made in Japan, and one piece costs, I think, 500 euros.
Ooh, okay.
Put 2 in a box, or like on the mastering 8, without any electronics. No? So you need to do all the electronic stuff. So this wasn't the product that people wanted to pay for, like $2,000 or something on a stereo. I think it was even more than $2,000 finally when you put all the margins on top of it. But Adam, he got one. Yeah.
We will have to end this very interesting session. I just have one last question, which is going to be maybe quick to answer. What can we expect from SPL in 2022? Any upcoming stuff? My answer personally would say...
I'm not sure whether I'm allowed to say.
Well, you are allowed.
A lot, actually. We've been really... we have more products on the shelf that we can put out. So more finished prototypes. One is standing over there. Which is I'm going to talk about that when we do the mastering class.
Next week.
Yeah. Here's another one. This is a very special thing, and I'll talk about that in the masterclass. On Studio, we're gonna come up with a second, a newer version of the Phonitor 2. There will be a Phonitor 3, I might say. Don't post this anywhere, please. And I know
you are the one who's taking the risk of saying it. I didn't.
And I know you're gonna shit all over me after this session. Why did you do that?
No. But I mean, you're the boss. You're supposed to know what you're doing. But fair enough.
No, I don't. How can I?
Make sure you stop the recording.
Yeah. I will edit
Make sure you
it
chop
and
the
cut
recording
it
off.
at that time.
Yeah, we'll have a few things coming. That's how I might say that. And
All right, good enough. Yeah. All right, guys. Thanks a lot for your attention, patience, maybe.
Yes.
It was a great session as well. It has been recorded, so if you want to give it to someone else or to look at it again, Vivin will have the video this afternoon. So on my side, I wish you all a very good weekend, and I hope to see you soon next week. The next session will be on Wednesday, same time, same place, and it's going to be the last two sessions on Wednesday and Friday, and it's going to be really cool because it's, well, as usual, because it's going to be on mastering. First session on mastering on Wednesday and the second session on mastering on Friday, and that will end the whole SPL session for India for now. So thanks a lot, and take care.
Thanks, Ashwin.
Or
yes,
thank you.
Thanks for
your
doing this.
Yep.
Anytime. Herman's the guy to thank, like Herman and Xavier.
Absolutely. I'm sure we're all waiting for Herman and Xavier to visit India once travel is more safer, as KJ sir has mentioned.
Yep.
I'm sure we're all dying to meet you. Soon.
We also want Herman's book. We're waiting for Herman's book, actually.
And
But it's funny that you mentioned that, because it's been several times that I'm saying to Herman to write these stories down. 15 to 20 minutes every day, just on a, just do it, man.
Yeah.
Yeah.
I'm flattered that you all think this is also interesting, because it's just my small life, and I just remember those things because I'm just a fucking regular guy, and we just went. All this happened while creating or making your own little company, and yeah. I don't think it's worth writing a book about it. It's,
I'm not the only one to think this. So
from the garage to Zoom meetings all around the world.
Yeah, from garage to Zoom meetings. Yeah.
But thank you so much. Thank you so much, guys, for being such wonderful people and sharing your time, and the audience for being very engaging, getting those questions in and making this a lively session. So I hope everybody has a wonderful weekend and a very safe weekend also.
Yeah. Thanks a lot, everybody, that you stand me.
Cheers. Thanks. See you all next week.
Right, see you next week.
See you.
See you next week. Bye.
Bye-bye.
Bye-bye.